everyone. We will be solving question 44 from GATE 2021 Chemical Engineering paper, and the subject is heat transfer. A double effect evaporator is used to concentrate a solution. Steam is sent to a first effect at 110 degrees Celsius, and the boiling point of the solution in the second effect is 63.3 degrees Celsius. The overall heat transfer coefficient in the first and second effect are 2000 watt per meter square Kelvin and 1500 watt per meter square Kelvin respectively. The heat required to reach the temperature of feed to the boiling point can be neglected. The heat flux in the two evaporators can be assumed to be equal. The temperature at which the solution boils in the first effect is degree Celsius. So here we have been given double effect evaporator, and we have been asked to find the temperature at which the solution boils in the first effect. So basically we have been asked to find the outlet temperature of the vapors of the first effect Okay. So just to give a basic schematic of a double effect evaporator, so it will take a so this is my first evaporator. If I'm only using single one, then it is single effect evaporator. Since I'm using two evaporators, we call it as double effect evaporator. Okay, so here we have been asked steam is sent to first effect at 110 degrees Celsius. Okay, so I can write this Ts as 110 degrees Celsius, and the boiling point of the solution in the second effect is 63.3 degrees Celsius. So for this is my first effect evaporator, this is my second evaporator, and since the boiling point is 63.3 degrees Celsius, the vapor will leave at boiling point. Okay, so let's just consider the outlet of this evaporator. Here it will be T1 and here it is T2. So T2 we have been given as 63.3 degrees Celsius, and we have been given the overall heat transfer coefficient in first and second effect are. Okay, so here U is equal to 2000, and in this U1 is equal to 2000 and U2 is equal to 1500. Okay, and the heat required to raise the temperature of feed to the boiling point can be neglected. Okay, the heat flux of the two evaporators are assumed to be equal. So okay, the for for, for first evaporator, if the heat flux is Q upon A1, so that will be equal to the heat flux of the second evaporator. Okay, this we have been given. The temperature of this solution boils in the first effect. So basically we have been asked to find T1. So we will just write the heat balance across each heat balance across these two equations using this information that has been already provided. Okay, so based on this overall heat transfer coefficient, we can write Q as UA delta T, where delta T will be my inlet minus outlet temperature. So for first effect evaporator, the inlet temperature is 110 and the outlet is T1. Similarly, for second, this vapor is going into the inlet stream. Okay, so for second, the delta T would be delta T1 minus of delta T2. Okay, so that we will write over here U1 delta T1 is equal to U2 delta T2. U1 we have been provided as 2000. For the first effect, we have been given delta T1 as 110 minus T1. Similarly, 1500 into delta T2 will be this T1 minus T2. Okay, so we can just write this as this becomes 220 minus 2T1 is equal to 1.5 T1 minus of 1.5 T2. Okay, and in this case we have been given T2 as 63.3. So it will become 1.5 T1 minus 1.5, 63.3 degrees Celsius. So basically that will become 2 plus 1.5 is 3.5 T1 is equal to 220 plus 1.5 into 63 will be 94, will become 94.95. 94.95 degrees Celsius. So that will imply T1 will become and this will come around 90 degrees Celsius. Okay. So yes, the temperature at which the solution boils in the first effect is around 90 degrees Celsius. So that is our final answer, 90 degrees Celsius. Since we have been asked to round up to nearest integer, we will report the answer as 90.